welcome to another GCSE Computer Science video with me, Mr Goff, from mrgoff.com. This video will focus on representing sound. The sound that we make when we talk is analog. It forms a continuous waveform. The height of this wave is continuously changing. Digital data, however, is discrete. It is either at a value of 1 or a value of 0. To record someone's voice through a microphone onto a computer, like I'm doing for this presentation, requires an analog to digital converter. Then when we want to play back the sounds, we need a digital to analog converter so that they can be played through a set of speakers. To convert an analog sound wave into a digital sound file, it must be sampled. This means the height of the wave is measured and recorded at regular intervals. The sample rate is the number of times per second a sound is sampled. The more frequent sampling is, the higher the quality of the file, but also the higher the file size because you've recorded more samples. Sample rates are measured in hertz, with 1 hertz meaning 1 sample per second. WAV music files that you would find on most CDs are sampled at approximately 44,100 hertz. Sample resolution is the number of bits used to store the height of the sound wave. You can represent 2 to the n different heights, where n is the number of bits used for your sample resolution. The higher the sample resolution, the closer you will represent the actual line, and therefore the higher the quality, but also the higher the file size, because you'll now be using more bits per sample that you take. You need to be able to calculate the file size of an audio file. You can do this using the formula file size equals the number of seconds the audio clip lasts for, times by the sample rate, times by the sample resolution. A file recorded at a sample rate of 10 Hz and sampled with 5-bit sample resolution that lasts for 8 seconds would be 400 bits, that is 10 times 5 times 8. You might be asked for the answer in bytes, in which case you'd have to divide that by 8 and come up with 50 bytes. That brings us to the end of this video on representing sound. Join me in the next video when I'll be taking a look at compression. Use the resources at mrgoff.com to help you revise computer science, and until next time, it's bye for now.